Hello, welcome back to Algebra. The title of this lesson is Practice Graphing Parabolas. This is part one. We have a few parts to this lesson where the problem complexity will gradually increase. So we've talked about the general form of the vertex form of a parabola, right? We all know we can graph anything by just making a table of values and plugging in the table of values. But we have this vertex form of a parabola, which makes it very easy to sketch the thing without making a table of values because we can read the vertex directly out of the equation. So we're going to get practice with that here. We're going to be doing several things. We're going to be graphing all of these parabolas. And what I mean by graphing is more like sketching it. We don't need any details. We just need to be able to sketch the general shape. We want to label the vertex. We want to label the axis of symmetry of every one of these parabolas. And we want to show the intercepts. In other words, where does the parabola cross the x-axis? Because it opens up, opens down. It's going to cross the x-axis somewhere. All right, so let's go ahead and refresh our memory. So I'm going to say recall that the vertex form of a parabola, it looks something like this. Y minus k is equal to a times x minus h quantity squared. If this equation looks foreign or crazy to you, it's just because you haven't watched my lessons on shifting parabolas around the xy plane. You should go back and do that. But basically what you have here is you have a basic parabola, ax squared, that's the basic shape of a parabola, right? And you're shifting it h units to the right, that's what the minus sign means. We talked about that in great detail. And you're shifting it k units up in the y direction. So minus sign means h units this way, minus sign here means k units up. And of course the a here in the front determines if it opens up or opens down, and also the steepness of the parabola. So we're going to get a lot of practice with all this stuff. What we want to do with every one of these problems here is we want to graph it, sketch it I guess is a better word. We want to show the vertex of every one of these parabolas. We want to show the axis, or write down the axis of symmetry, which we've defined in the past. And we want to show the intercepts. Because if you know all of this stuff, then you can sketch the graph. So that's what you're going to be doing on your exams, is you'll be given an equation and you'll be asked to sketch it. And you'll be asked to sketch it without putting a table of values, without making a giant table of values and drawing lots of points. You're not going to be doing that. We're sketching it just by looking at the equation. So the first equation we have is something like this. Y is equal to negative 3 times x squared. So we know it's a parabola, y, because it has a square term. The highest power, of course, is very simple. There are no other terms here. But the highest power is a square, so we know it's a parabola. And we also know, because we've talked about it before, that the negative sign in the front is negative 3 here. The negative sign means the parabola opens down. So whatever's in front of the x squared term, no matter what the number is, if it's negative, the parabola opens down like a frowny face. If it's a positive, then it opens up like a smiley face. So we know this parabola is going to go upside down like this. But we want to obviously talk about more than just that. We want to sketch it. So let's go over here and draw a little axis. We don't need to be exact about it. This is x and this is y. We're going to sketch this thing right here. So the first thing we need to do is figure out what is the vertex of this parabola. So what you need to do is figure out a way to make this equation look like this one, because when you have it in this form, you can read the vertex directly out. So what I want you to do is think. Think of this equation like this. Instead of y, you need to think about it as y minus 0. You don't need to have the parentheses there if you don't want. In fact, let me take them away, just so it doesn't confuse anybody. And that's going to equal to negative 3. Now this x squared, you can think about writing it as x minus 0 quantity squared. Well, why am I doing that? Because when I subtract 0 from y, it doesn't change anything. It's still y, right? When I subtract 0 from x, it doesn't change x at all. So this is the same as this, and this is the same as this. So even though it looks different, it's actually the same exact equation. But by writing it here, now it matches this form right here. So because of that, you read the vertex directly off of this guy. You read the vertex. So you can see the vertex is going to be at, in other words, the parabola here, the basic shape of the parabola is shifted 0 units in x and 0 units in y. So that means it's just located at 0, 0 like a regular parabola is. So I can go and put a dot here, and I can say that the vertex is located at 0, 0. In other words, there is no shift of this parabola from the basic position of any parabola. There's no shift at all, so it's going to go here. And we also know it's an upside down parabola because there is a minus sign in the front. So I can say it opens down. And we talked about this in the past as well, but because there's a 3 here, the value of the number in front tells you how steep it is. In other words, if it's a very large number, positive or negative, then the parabola is very closed off, very narrow. If it's a very small number, like a 1, like a typical like a 1x squared, just a 1, then it's nice and open. And of course, if you go to 1/2, it opens up even more. So it's a fairly narrow, steep parabola here, and it opens down. So the next thing we need to do, we know it's going to go like this here. And so probably the easiest thing to do, since we can see the vertex is right on the axis here, is go ahead and sketch the thing. So we know it's going to open a little bit steeper than our traditional parabola. A regular parabola might come and open up a little bit more open like this. This one's a little bit steeper. The vertex is right here. It opens upside down. That's pretty much all the information that we have here. But we have one more thing we want to talk about. We're going to graph it. We're going to put the vertex. We're going to talk about the axis of symmetry. Axis of symmetry is what is the line that cuts this parabola in half. So the axis of symmetry is going to be an equation of a line, a vertical line, always a vertical line. So it's going to be x is equal to 0. A vertical line, remember, vertical lines are always x equals something. A vertical line at x equals 0 is this line, the y-axis. A vertical line of x equals 5 is a vertical line over here. A vertical line of x equals -3 is a line over here at -3, and so on. So the axis of symmetry is x equals 0. That's a vertical line that goes right and splits this thing in half, because that is the symmetric, you can fold this thing over on itself like that. And then the last thing we want to talk about is the intercepts here. Usually these parabolas, like if it was upside down over here, it would intersect the axis in 2 points, and we would have to find those points. But here, because the vertex is right here, it only touches the axis in one location. We know that the only intercepts here are at x is equal to 0. There's only basically one intersect. It's a double root basically right here because it touches in one location. So I don't need to put anything else there. So we have the intercepts, which is only touching at one spot, the axis of symmetry, it opens down, the vertex, and we've sketched it. Now, of course, you can make a table of value and tighten this thing up and get the exact shape. That's not the point. The point is to sketch it. You're going to do this kind of thing in algebra where you're just sketching things. You're also going to do it in calculus. You spend a whole chapter sketching curves using the concepts that we learned later on in calculus. So sketching is something that you just have to get used to. All right, let's go on to the next problem. It's slightly more complicated than this one, but not complicated in general. What if the equation is y minus 4 is equal to negative x squared? So we want to sketch it, right? Now, we want to compare it to this. So this is y minus some shift is equal to a x minus some shift squared. So this looks almost the same, but you want to think, and I'm going to write the word think. You want to think about this equation in a different way. You want to think about it as y minus 4 is equal to, the negative sign stays there from above, but this x, just replace it with x minus 0. In other words, because there's nothing here, there is no shift in the x direction, because x minus 0 is what I already had there. But I do have a shift in the y direction and no shift in the x direction. So if I come over here and draw or sketch, I should say, an xy plane, so here's x, here's y. I'll just put some tick marks, 1, 2, 3, 4, 1, 2, 3, 4. I'm just sketching, 1, 2, 3, 4. I don't need to be exact. Something like this. Where's the vertex of this parabola going to be? Well, there is no shift in the x direction, so that means the x-coordinate of the vertex is 0, right? But the y-coordinate of the vertex is shifted up, because remember, minus signs mean shifted up. If that doesn't make sense to you, then it's because you need to go back and look at my lessons on shifting parabolas. I talk extensively on why the shifting happens. When you have a minus sign here, this is a minus sign also. It just means there's no shift though. But here we're shifting upward in the y direction 4 units. That means the vertex has to be positive 4. So we have 1, 2, 3, 4. This parabola is shifted up 4 units. I'm putting a dot there because that's the vertex, right? So I'm going to label this. The vertex is at 0, 4. That's the vertex of the parabola. So the next thing you have to look at is say, well, is it open up or is it open down? In other words, does it look like a smiley face with a vertex here, or does it look like a frowny face with the vertex there? Well, I have a negative sign, which is in front of the x squared term, so it opens down. And also, it's only a -1 out here. See, in the previous problem, it was -3. This was much steeper, much more closed off, much more constricted like this. But this is a -1 out here, which means it's not going to be quite so steep. It'll probably open something more like this, like a traditional parabola shape. It's just flipped upside down. Now, you could sketch it with this information, honestly, because you know the vertex is here, you know it opens down, and so you could just sketch it. But the problem is you don't know exactly where this thing crosses the axis here. If I knew that it crossed here and it crossed here, then I could sketch through this point and I would have a pretty good idea for the shape. So that's why in these problems you want to sketch the graph, you want to talk about if it opens up or down, you want to know the vertex, you want to know the axis of symmetry, of course, and you want to know the intercepts. That means where does the parabola cut into the axis? Because if you know that, then you can sketch the thing through those points. So we have to figure that out, and unfortunately the only way to really figure it out is to calculate it. So we know this thing is going to come down. It's going to cut somewhere here. The function is going to go in both directions. It's going to cross the axis, let's say right here and right here. In both of these locations, the y value of the function is 0. If it did cross here at this point, then the y value of this point is going to be negative something, comma 0. The y value of this point, or the point here, would be, let's say 2, comma 0. In other words, both of these points have a y value of 0. So the way we figure out where they are is we just set y is equal to 0. That's all we have to do. So we just take a 0 and we stick it in there. It's going to be a -4. And then on the right-hand side, it's a negative sign. Inside here, we just make it x minus 0 squared. And now all we have to do is solve for the x values. These are going to be the x values where the y value is 0. So you're setting the y value equal to 0, forcing yourself to calculate the values of x where the y values are 0. Those are going to be the crossing points for the, call it the x-intercept. So it's the x-intercept. In other words, the intersection points with the x-axis. So then we can calculate this. We have -4 on the left, and then this is x minus 0, so we just write it as negative x squared. And then what we have to do is we have a negative sign and a negative sign. We can divide both sides by -1, right? So I divide this by -1, this by -1. I'm going to get a +4 and a positive x squared here. Just divide both sides by -1. And let me flip it around to make it easy to see. X squared is 4. And I think you know what to do next. You take the square root. So you get x is plus or minus the square root of 4. We've done radical equations before. So you have x is plus or minus 2, right? So that means that at plus or minus 2 on the x-axis, the y value of the function is 0. So that means that right here there's an intercept at +2 for x and at -2 for x. Of course, the y value is 0 for both of those because it's on the axis. And now I have enough information. I can go here and just draw this guy going straight through like this, and I'll try to do my best to go down like this. I didn't quite hit it, but you get the idea. It goes through like this. That's what this parabola looks like. In order to do a proper sketch, you have to know where the vertex is, so you know where to start from, and you have to know where the intercepts are, so you know where to go. All you need is a couple of points like that to draw a pretty good sketch of a parabola. And then the last thing we need to do is what is the axis of symmetry? So the axis of symmetry is just the line that cuts this thing in half. And this thing is centered right here. So the y-axis, just like before, is the same thing here. The axis of symmetry is x is equal to 0. Remember, vertical lines are x is equal to something. X is equal to 0 is a vertical line right here, which bisects this guy. So that's the axis of symmetry. We have the intercepts we talked about here. The vertex, we know it opens down. That's everything that was asked of us in this drawing, in this problem, and also to sketch the thing. So we're done. Every one of the problems after this, and also in the next couple of lessons, are going to follow the same basic idea. We're going to figure out where the vertex is. We're going to calculate the intercepts, and we're going to then try to sketch it and then look at the symmetry and all the other things and write them all down. That's what you're going to be asked to do on all of your problems. Okay, next problem. What if we have y equals x minus 3 quantity squared? So we obviously want to figure out where the vertex is. So the easiest way to do is to think about it this way. Really, this y is a y minus 0. On the right-hand side, I'm going to leave it as x minus 3 quantity squared. This is now in the form of that vertex form of a parabola. We can see the vertex has no shift in the y direction, but it does have a shift in the positive x direction because negative signs means you go and shift the thing to the right. So if I was going to kind of draw x, y. I'll do some tick marks, 1, 2, 3. Put some tick marks all over the place here. Doesn't have to be exact. Then where is this vertex going to live? Well, again, it shifted 3 units to the right. That's over here. And 0 units up. That means the vertex lives right here. And this parabola is either going to go upside down like this, or it's going to be right side up like this. And we're going to get to that in a second. But for now, let me go ahead and write down that there's vertex here at 3, 0. 3x is equal to 3, y is equal to 0. And that's something you need to solve the problem. The next thing you do is you look at the coefficient in front of the x squared term, whatever's in front of here. In this case, it's a positive 1. So we know because it's positive that it opens up. And you also know that there's a 1 here. So the larger the number, the more closed up the parabola is. So we know it's going to be a regular shape, kind of open parabola because it's just a 1. And it opens up right there. All right, the next thing we need to do is we need to talk about intercepts. Now in this case, you can see the vertex is on the axis. So you know the thing really doesn't have any other intercepts besides this point. So you could kind of just sketch the thing. In fact, let's just do that real quick. The parabola is going to look something like this. That's probably a little too steep. It should be maybe a little bit more open than that. But basically that's going to be the parabola. But just to be absolutely, clear about it, let's go find those intercepts, the x-intercepts. Where does this parabola cross the x-axis? Of course, you can see it right here. But let's do it. We're going to set the y value equal to 0. We're going to force the function to have a y value of 0. We're going to calculate this. So it's going to be 0 for y, x minus 3 quantity squared. So we have to find the x values. Okay, so then we have a 0 here and here. We're going to take the square root of both sides. Actually, no, we're not going to take the square root of both sides. Let's do it this way. We're going to open it up and say x minus 3. This is x minus 3 times x minus 3. This is a much better way and cleaner way to do it. And you can see that to solve this equation, x minus 3 has to equal 0, and x minus 3 has to equal to 0. So x is equal to 3, and x is equal to 3. So what you have is a double root at x is equal to 3, which is exactly what you have. This is 1, 2, 3. There's a double root here. Anytime a parabola goes down to the axis and just touches it, then you still have 2 roots, but they're right on top of each other, infinitely close together, so they're right on top of each other. And so we've shown it mathematically that the crossing points are at x is equal to 3, and we already knew it from the fact that the vertex was here as well. So then we need to talk about the axis of symmetry. All you have to do is go up here and say, well, what line cuts this thing in half? It's going to be a line that goes right through the middle at x equals 1, 2, 3. It's always going to be a vertical line, and any vertical line in math always has the form x equals something, because when you have a vertical line, all of the points on that line have the same x value. The point on the line right here has an x value of 3. Here has an x value of 3. Here has an x value of 3. Any point on this line is 3 comma something, because the y values are all different, but the x values are all 3. So to show that they're all equal to 3, the line just says x equals 3. That means all the points where x is equal to 3, and that means there's a line here of points like this. So this is the axis of symmetry. The intercepts are here. It opens up, and then the vertex we've already written down. All right, we have one more problem. This one's going to take a little more time, not because it's complicated, but just because the math gets a little bit cumbersome at the end. So let's go ahead and work on that right now. Let's say we have y plus 2 is equal to parentheses x minus 1 quantity squared. Now this is probably the first one of the first ones anyway, where we don't have to make any changes to the equation. It's already in vertex form. We can see that we have a shift in the x direction of the basic parabola shape to the right 1 unit. And we can see we have a shift of the parabola also down 2 units, because the plus sign means down 2 units. So if we were going to do that, we're going to go ahead and draw a quick little axis here. Let me go ahead and draw a couple tick marks. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, something like this. And let's go ahead and say that the vertex of this guy shifted 1 unit to the right, that means here, and 2 units down, 1, 2. So the vertex of this parabola is actually right here, down below. And the parabola can either go upside down, or it could be right side up. You have to look at other parts of the guide to figure that out. But we can write down that the vertex is at 1, negative 2. 1 unit shifted to the right, 2 units shifted down, so from the origin. So we have 1 comma negative 2. So then you have to ask yourself, okay, does it open up or does it open down? So all you do is look at the number in front of the parentheses, but it's an invisible 1, a positive 1. So it's positive, which means it opens up. And that means that this equation is going to look something like this. Now, I don't want to sketch it yet because the problem is I don't know how wide it is or how narrow it is. So it could be a very steep parabola that goes like this, or it could be a really shallow parabola that goes like this. We need to know the x-intercepts. Where does the thing cross the x-axis here? So let's find the x-intercept. Let me switch colors. The x-intercept. You set y equal to 0 because we're forcing y to be 0. We're looking for points in the function that lie on this axis, so y must be 0. We just stick 0 into the equation. X minus 1 quantity squared. All you do is stick a 0 in there. And then you solve for the values of x. Whatever we get is going to be the crossing points on the x-axis because we set y is equal to 0. So notice we have x minus 1 squared. So let's do this properly. It's going to be x minus 1, x minus 1. We're going to have to FOIL this thing out. Right? So on the right-hand side, it's going to be x times x giving you x squared. This is going to give you negative x. The outside terms are also going to give you negative x, and these are going to give you positive 1. So you're going to get 2 is equal to x squared minus, you add those together, you get 2x plus 1. All right, but I have a 2 over here, so I need to solve this thing. So I need to move the 2 over. So what I'm going to have is 0, x squared minus 2x, and then 1 minus 2 is going to give you negative 1. All I did was subtract 2 from both sides. So let me catch up and make sure I'm good here. So what I want to do is try to factor this thing. I'm going to set it equal to 0. Of course, it's set equal to 0, and I'm going to try to factor it. So I see I have an x squared here. Here's an x and here's an x. The only way I can have a 1 is a 1 times a 1, like this. But then I run into problems because I have a negative sign there. So these have to be different signs. If I make it, for instance, plus and minus, like that'll make a negative 1. But then I'll have a plus x and a minus x. I add those together, I'm not going to get the 2x. So then I say, okay, well, I'll flip it around again. And you can already see it's not going to work. I'll do this. Make it, it has to be opposite to multiply these to give me negative 1, but then I have the same problem. These don't add to give me this. So basically, you just kind of cross through that and say you can't factor it. I mean, most of the time, honestly, in real life, most of the time, you get a quadratic like that and you can't factor it, most of the time. But it doesn't mean it doesn't have solutions. It just means it doesn't have solutions that are whole numbers. So because you can't factor, it doesn't mean you give up. It just means you think, okay, how else can I solve it? Well, we try to factor first. That didn't work, right? The next thing you can do is completing the square, and then you definitely can factor it. But we already learned there's an easier way. The quadratic formula is always easier. It always works, and it basically comes from completing the square. So what we want to do, we want to figure out the crossing points here. And this is why I said this problem becomes, it's harder, but it's not because it's conceptually harder. It's just there's more math to do. So now I have to get the x values by the quadratic formula, which remember is going to be negative b plus or minus b squared minus 4 times a times c. All of that goes under a radical. And then I have over 2 times a. That's the quadratic formula. A is 1, b is negative 2, c is negative 1. So for b, I have a negative b, but b itself is negative 2, so I'm going to wrap that in a parenthesis. So it's negative b. And I have plus or minus, I have b squared, which is negative 2, quantity squared, minus 4ac, minus 4 times a is 1, c is negative 1, 4ac. A radical goes around all of that, and then this whole thing is 2 times a, which is 1. So that's negative b plus or minus b squared minus 4 times a times c over 2a. And so we just have to crank through it, and it's just work, but you'll get there. So negative times negative is positive 2, plus or minus. On the inside here, this is going to give you a positive 4. And then you have negative times negative will give you positive 4 also. So you have positive 4 inside of there. You have a radical here. And then you have on the bottom a 2. So what you have is 2 plus or minus the square root of 4 plus 4 is 8. And then you have a 2 here. Now, if you simplify this radical, which is an 8, remember we learned how to simplify radicals. It's 2 times 4, and 4 is 2 times 2. And we're looking for pairs, so we can pull out a 2 there. So what we have here is, for this, is going to be 2 plus or minus the square root of 8 reduces to a 2 coming out, a square root of 2 left underneath, and we've learned all of that when we learned radicals. So you have 2 plus or minus 2 square root of 2 divided by 2, a lot of 2's. We want to simplify as much as possible. We notice we have a 2, and a 2 here. So what we're going to do is we're going to split this thing up to help us cancel it easier. We're going to split this whole fraction up. It's going to be written as 2 over 2 plus or minus 2 square root of 2 over 2. All I've done is taken this and break it apart into 2 fractions so that I can cancel this and this and cancel this 2 with this 2. Now remember, when you have something that's added on the top here or subtracted, then you can split it up because what you have, you can think of it going backwards. If you had a common denominator of 2 and I told you to add these, you would say, well, the denominator has to be 2. And then it will be 2 plus or minus this on the numerator, which is exactly what I have. So it's going the reverse of kind of fraction addition, and it just helps to visualize the cancellation. So what you have here is, this is 1, 2 divided by 2 is 1. And then this 2 divided by 2 is 1. So you have square root of 2. So you have 2 answers, 1 plus the square root of 2 and 1 minus the square root of 2. But for the purpose of sketching, and these are the actual intercepts, so I'm going to circle this. These are the intercepts. X-intercepts. X-intercepts. But for the purpose of graphing, it's kind of hard to figure out where that really is. So what we do is we say 1 plus the square root of 2. Is approximately equal to 1 plus, and the square root of 2 is about 1.4. It's got infinite decimals after it. So I'm truncating it, but it's about that, 1 plus 1.4. And that's going to be approximately equal to 2.4. All right, and then if I take the other one, 1 minus the square root of 2 is approximately equal to 1 minus 1.4, which is approximately equal to negative 0.4. These decimals are not exact because the square root of 2 is an infinite non-repeating decimal. It goes on forever. It's irrational. So the 1.4 is not exactly what this is. That's why I have the squiggly equal signs here. But basically it crosses somewhere around 2.4 and somewhere around negative 0.4. So 2.4 would be 1, 2. Let me switch it to a different color. 2.4 would be 1, 2. Here's 2.5. So 2.4 is going to be just to the left of that. And then negative 0.4 is going to be, here's negative 0.5, negative 0.4 is a little bit shifted to the right of that. So now we have our vertex, which is right here. This is vertex at 1 comma negative 2. Whoops, 1 comma negative 2, like this. And this parabola is going to go through this point down here and then through this point up there, like this. It's going to cross at positive 2.4 and negative 0.4. So you can see that those make a nice symmetric parabola, and then we can look in the middle and say, where is the axis of symmetry? So we have to find the dotted line that goes right through the center, and I know I'm not being perfect with this, but the axis of symmetry is at x is equal to what? X is equal to 1, because that's where the line is. Here's x is equal to 1 right here. So the axis of symmetry is at x is equal to 1. The vertex is at 1 comma negative 2. We got that from the equation. The x-intercepts are really exactly equal to 1 plus or minus the square root of 2, but we changed it to decimals so that we could actually put it on the graph. The thing opens up just because the coefficient is a positive number there, and that's it. That's all you really have to do. The only reason this one was difficult or harder was because you couldn't factor it. We couldn't figure out how to factor it. Now you can see why we couldn't factor it, because the crossing points were not nice whole numbers. They're weird, long, infinite repeating decimals, so you're not going to have whole numbers, and so that's why we couldn't factor it. So this is practice graphing parabolas. We're putting everything together where we're looking at the vertex form of a parabola. We're figuring out where the crossing points are. We're looking at the vertex. We're looking at the opens up versus open down. The only other thing I'll say before I close is that in every one of these problems, let me go back to the beginning here. Let me start with this one. Like in this problem, for instance, I'm writing it in my problems like this is the vertex form, y minus 4 equals this. You can also write it as, just move the 4 to the other side. Y is negative x squared, and then the plus 4 comes over. Some people will call this a vertex form, right? Some books will call it a vertex form. Or on this equation, you might write it as y is equal to x minus 1 quantity squared. Just take the 2 and subtract it over. Right? So you can still read the vertex off here, but you have to be careful with the signs because this means shifting down and this means shifting to the right. And so I'm kind of teaching it to you this way because negative signs means to the right, positive signs means down. But if you have given the equation here, then you got to be careful, because if the y shift is written on the right-hand side, as we've talked about many times before, this is a shift down, this is a shift to the right. So I'm just trying to kind of like keep you aware of all the gotchas here. And that's, some books have it one way and some books have it another way. You look on the internet and you'll see the Vertex Form one way and the Vertex Form another way. And so there's no right way. It's just where do you put that y shift, on the left or on the right. So make sure you can do every one of these problems, and then follow me on to the next lesson. We're going to get more practice with graphing parabolas.